Hello everyone. Today we're looking at the sum and difference formulas, as well as 4 sample problems to show how we work them. Up until this point, we've been dealing with angles and radians that have been on the unit circle. The sum and difference formula are going to be used to find angles and radians that are not necessarily on the unit circle. So there are 3 equations total. We have one for sine, one for cosine, and one for tangent. Regardless of which equation we're using, the fundamental idea is that we're going to break down whatever angle or radian we're working with into components that will either add up to or subtract down to the desired number. And then, depending on if we're looking at the sine, the cosine, or the tangent, we're going to use a different setup of the formula to solve it out. If we're dealing with sines, then we're going to do the sine of the first component times the cosine of the second component. And we're going to keep the same sign as whatever we have in our formula. The cosine of the first component times the sine of the second component. What I mean by components is that we are going to represent any of our unknown angles or any of our desired angles as the sum or difference of 2 components that exist on the unit circle. At which point we'll check our unit circle, find our corresponding values, do some fractional math, and get our answer fully rationalized. Cosine, something to pay attention to, is that we've got this sign change occurring. You'll notice that we're going from positive, negative, or plus or minus to minus plus. This means that if our cosine is dealing with the sum of the components, then the equation we're going to use is going to deal with the difference between them. If we're dealing with a difference of components, we're going to be looking at the sum for the equation. And the cosine equation itself is slightly different, in that we're doing the cosine stuff first, followed by the sine stuff later. I'll talk about the tangent one later on when we get to that one. For now, let's take a look at a practice problem. We're looking for the sine of 5 pi over 12, and 5 pi over 12 doesn't exist on our unit circle. So we're going to use our sum or difference formula using the sine setup to solve for our sine of 5 pi over 12. Now the first thing we're going to do, because radians can be a little messy, we're actually going to convert our 5 pi over 12 into degrees. So we're going to use our degree conversion formula of whatever we were working with, 5 pi over 12, times 180 degrees over pi. Solve it out, simplify, and we'll get 75 degrees. So we're looking for the sine of 75 degrees. Now 75 degrees, it's not on our unit circle. It's somewhere between 60 and 90, but itself of 70 is not on there. So we need to figure out 2 numbers that will either sum up to 75 or reduce down to 75. And for me, that looks like the sine of 45 plus 30, because 45 and 30 degree angles are both on my unit circle. So the setup for this is going to follow my sine rules, in that the sine of 45 plus 30, my 45 being my u component and my 30 being my v component, is going to be equal to the sine of 45 times the cosine of 30 plus the cosine of 45 times the sine of 30. At this point, we head it over to our unit circle, find our corresponding values, and plug them in. The sine of 45, that's square root of 2 over 2. The sine of 30 is the square root of 3 over 2. I'm going to add that to the cosine of 45, which is the square root of 2 over 2, which is going to be multiplied by the sine of 30, which is 1/2. Now it's just fractional multiplication. Root 2 over 2 times root 3 over 2 is going to give us root 6 over 4. We're going to add that to root 2 over 4. Our fractions have the same denominator, so we can combine them. So that will be square root of 6 plus square root of 2 over 4. We will leave it as that as our exact value. No need to plug into the calculator. This is as precise as we want to solve our problem. Now in this next problem, the cosine of 165, it already gives us the problem in degrees. So we can just break it down to try to find two angles that exist on the unit circle that we're going to add up to or subtract down to 165. And for me, that looks like we could use the cosines of 120 plus 45 degrees. We then go to our cosine equation such that the cosine of 120 plus 45 degrees, with 120 being our u, and our 45 being our v, is going to break down into, let's swap colors, the cosine of 120 times the cosine of 45 minus, because of that sign change, the sine of 120 times the sine of 45. Now we go back to our unit circle and find our corresponding values. The cosine of 120, negative 1/2. The cosine of 45, root 2 over 2, minus the sine of 120, root 3 over 2, times the sine of 45, root 2 over 2. Do our fractional math. We end up with negative root 2 over 4 minus root 6 over 4. They have the same denominator, so we can combine them to give us negative root 2 minus root 6 over 4 for our exact value. Again, no need to simplify further. This is fully simplified. No need to plug into the calculator to get decimals. This would be our final answer on a test, quiz, assignment, etc., etc. Last problem for this page, the cosine of 7 pi over 12. Well, it's in radian form, so my first step is going to be to convert 7 pi over 12 into degrees by multiplying that by 180 degrees divided by pi, which in turn will give me 105 degrees. So now I'm looking for the cosine of 105 degrees. 105, you look at the unit circle, not on there, but 60 and 45 are both on my unit circle. So the cosine of 60 plus 45. 60 is going to be my u, 45 will be my v. So the cosine of 60 plus 45 is equal then to the cosine of 60 times the cosine of 45 minus the sine of 60 times the sine of 45. Head over to the unit circle to find our corresponding values. The cosine of 60, 1/2. Cosine of 45, root 2 over 2, minus the sine of 60, root 3 over 2 times the sine of 45. Yeah, sine of 45 at root 2 over 2. Do our fractional math. We end up with root 2 over 4 minus root 6 over 4. They have the same denominator, so we can combine them to give us root 2 minus root 6 all over 4 for our final answer. Again, we'd leave it at that. We wouldn't push it any further. Now this last one, tangent, different equation. We're going to have to do a little bit more work on this, but it's mostly going to be algebra. So, for our sum or difference for tangents, we're still going to break things up into our components of u and v. But now, because tangent is essentially y over x, we're going to have numerators and denominators being involved as well. Now, what's important here is that in our numerator, it's going to keep the same operating sign as our sum or difference in the base problem. But the denominator is going to switch. So just like tangents are sine or cosine, you can kind of think about it in terms of similar things to our sines, in that we're keeping the same sign, we're keeping the same operator, and similar things to our cosine where we're swapping operators. But everything else is just the same. Base, going off our values, finding corresponding values, so on and so forth. So, tangent of 15. It's already in the desired form, so we just need to figure out two numbers that will add up to 15 or subtract down to 15. For me, that's going to be the tangent of 45 minus 30, with 45 being my u and 30 being my v, which means that my equation is going to be the tangent of 45 minus the tangent of 30 divided by 1 plus the tangent of 45 times the tangent of 30. Now, on our unit circle, we don't have the tangent 45, we don't have the tangent of 30, but we did do that worksheet where I had you write out the full tangents. That'd be a great worksheet to pull up to help you with these problems. Alternatively, you can just Google tangents, or you can derive them, which I'm going to do over here to the side real quick. So the tangent of 45 is essentially going to be my sine over cosine. The sine of 45 is root 2 over 2. The cosine of 45 is root 2 over 2. Anything over itself is always going to be 1. Meanwhile, the tangent of 30, well, the sine of 30 degrees is 1/2. The cosine of 30 degrees is root 3 over 2. This is going to go into fractional division, which will eventually wind us up with square root of 3 over 3. Now, if you need a refresh on how this complex fraction becomes this final answer, shoot me that email, ask during class, come to tutoring. I'd be happy to help guide you through it. But now we're going to plug in those values to our blue equation, such that we essentially have in the numerator 1 minus root 3 over 3. In the denominator, we have 1 plus 1 times root 3 over 3. Our next step, we're going to need to combine them. The way we combine them is to turn our 1 into something that has a denominator of 3. And so anything over itself is going to be equal to 1. So I'm going to turn my 1's into 3 over 3's. This allows me to then combine my like terms to give me this new equation. Still have a long fractional bar of 3 minus the square root of 3 over 3 and 3 plus the square root of 3 over 3. So now I've got some fractional division that I need to work out. Well, dividing fractions is the same as multiplying by the reciprocal of the denominator. So that's what I'm going to do. And I have 3 minus square root of 3 over 3 times the reciprocal denominator. So that will be 3 over 3 plus root 3. My 3's will cancel out, and that will give me 3 minus root 3 over 3 plus root 3. This is an irrational fraction because we have a denominator that has an improper component to it. So we need to rationalize it. The way we're going to rationalize it is essentially by multiplying by the conjugate of the denominator. All these old terms from Algebra 1 and Algebra 2, we're using them again. Conjugates of denominators, that's going to be whatever the denominator is, with the sign reversed. So multiplying it by 3 minus square root of 3 over 3 minus square root of 3. At this point, we're essentially going to FOIL these. First, outer, inner, last. Once we FOIL them out, we'll end up with the following fraction. In the numerator, we'll get 9 minus 3 root 3 minus 3 root 3 plus 3. In the denominator, we'll get 9 minus 3 root 3 plus 3 root 3 minus 3. Such that when we simplify, in the denominator, we have our middle terms canceled out because of because the negative and the positive will cancel out. And we'll be left with 9 minus 3, which puts us at 6. In the numerator, we have 9 plus 3, so that'll give us 12. Then we'll have minus 6 root 3. Almost done, but not yet, because we can simplify that into something nicer, something cleaner. Both 12 and 6 are multiples of 6. Therefore, I can factor out a 6 to turn the numerator into 6 times 2 minus root 3. Denominator is the same. I can now cancel out that 6 and that 6 to give me my final answer of 2 minus square root of 3. A few more steps overall, but from here until here, that's all Algebra 1 stuff. So if you need some assistance, please let me know. You'll also find the full write-up of the notes in the appropriate folder.